Alright, we're going to look at solving inequalities with variables on both sides of the inequality symbol. Okay, so the first thing we have to do is we need to, just like with equations, we've got to push all our variables onto one side. So in this case, I'm just going to push everything onto the left-hand side. So I do that by removing the 3x from the right-hand side. So since it was a positive 3x, its opposite is negative 3x. And remember, what I do on one side, I have to do to the other. Okay, so when I subtract 3x from both sides, we're left with 2x plus 4 is less than or equal to, and on the other side we just have 10. Okay, and now I'm going to get rid of the constant, so I'm going to subtract 4 from both sides, and now we're left with 2x is less than or equal to 6, and then simply divide both sides by that coefficient of 2, and we now have that x must be less than or equal to 3. Okay, so like before, I'm going to verify that this works. So the first thing I'm going to check is that boundary point. So I'm going to do the left side and the right side. Now I do have work to do on both sides of the inequality here, so I do need to make sure I write out both sides separately. So I'm testing that that value of 3, if I put it back into my original expression, that the left side and the right side would be equal to one another. Okay, so if I substitute in the 3 on the left, we get 15 plus 4. 15 plus 4 is 19. On the right hand side, we had 3x plus 10. So instead of putting in the x, we're going to substitute in that value of 3. And that's going to give us 9 plus 10, which also happens to be 19. So the left side and the right side are equal. Okay. The second thing we have to check is make sure that that inequality symbol is facing the right way. So we're saying that all the values that are smaller than 3 should work. So I'm going to test one of those values that's smaller than 3. So we said x should be smaller than or equal to 3. So let's pick something that's smaller than 3. I'll try 1. Usually I pick 0, but let's try 1 to do something different. So we had 5x plus 4 was less than or equal to 3x plus 10. So we want to see if this statement is still true. When we substitute in instead of x, we write in that value of 1. Okay, we want to see if this inequality is still true, because our solution says anything smaller than 3 should be true. Okay, so this gives us now 5 plus 4, which is 9 on the left hand side. On the right hand side, we get 3 plus 10, which is 13. And 9 is less than 13, so this would be true. Okay, so we've verified that our inequality here was the solution to the inequality there. Okay, do another example. Okay, so again, just like before, I'm going to move everything onto the left hand side. So I'm going to do that by adding 3x onto both sides. And this leaves me now with, I've got negative 3x plus 3 is less than negative 12. Okay, and then I'm going to get rid of the constant by subtracting 3 on both sides. So now I have negative 3x is less than negative 15. And then I'm going to divide both sides by negative 3. And as soon as I say that, divide both sides by negative 3, that should be an immediate red flag. I want to reverse my inequality symbol. Okay, as soon as you're dividing or multiplying both sides by something negative, your inequality symbol must flip. Okay, so I still have my x on the left. Negative 15 divided by negative 3 would be positive 5. Okay, so if you didn't flip your inequality symbol, remember the verifying is where you're going to find that out. Okay, so I'm going to do my left side and my right side for the boundary point. On the left we started with negative 6x plus 3. On the right was negative 3x minus 12. So instead of writing x, I'm going to substitute in that value of 5. Okay, oops, there we go. And so that gives me negative 30 plus 3, which is negative 27. On the right hand side I got negative 3 times 5. And then I'm still subtracting the 12. Negative 3 times 5 is negative 15, minus 12 more, negative 27. So we do get the same thing on both sides, so we have the correct boundary point. Okay, this is the part where if you should have flipped, your inequality and you didn't, you will find it out. Okay, so we said that x should be bigger than 5, so I better pick something that actually is bigger than 5 and test it out. Oops, I got that backwards. X should be bigger than 5. Okay, so I'm going to try, I don't know, pick a nice number like 10 because it's easy to multiply. Okay, so we had negative 6x plus 3 should be less than negative 3x minus 12. And now we'll put that value of 10 into there. Okay, so it should be 10 plus 3. And then on the other side we got negative 3 times 10. Oh my. And then minus the 12. Okay. Alright, so negative 6 times 10 is negative 60. Plus 3 should be less than negative 30 minus 12. This gives us negative 57 is less than negative 42. And again, that's a true statement. So that's good because that statement is true. It means that this inequality here is in fact the solution to the original inequality. Okay. Now there is a simpler way we could have done this example. So right at the end here, where we needed to move our inequality, it needed to flip because of that negative. We could have avoided all of that. So this is why when we were doing equations, I had asked you guys to make sure that you are always getting rid of your smaller of the two variables. So if you look at negative 6x and negative 3x, negative 6x is actually the smaller of the two variables. Right? Negative 6 is a smaller value than negative 3. So that's actually the one I should have gotten rid of. So if I get rid of the 6x by adding 6x on both sides, now I have 3 is less than 3x minus 12. Okay, and then I'm going to add 12 onto both sides, and that gives me that 15 is less than 3x, and I'm going to divide both sides by 3, and that gives me that 5 is less than x. Now this solution does look a little bit different than our last one, right? Our last solution said that x was greater than 5. But if you look at these two inequalities, they are saying the exact same thing. We just have x on the opposite side, right? If you're thinking of the inequality symbol as an alligator, the alligator in this one is chomping the x because x is bigger, and this alligator is chomping the x because it's bigger. So x is the bigger value in both inequalities. Okay? Because of that, they say the same thing. So 5 is less than x is the same thing as x is greater than 5. So yes, the variable's on the opposite side, but our inequality symbol is still pointing at it's pointing at the smaller value, right? Pointing at the smaller value, or the alligator is eating the bigger value, whichever way you want to look at it. Okay, so my recommendation would be always get rid of your smaller of your two variables, and then you don't have to worry about multiplying or dividing both sides by that negative. It should take care of that for you. All right,